Now let's talk about hyperbolas. So a hyperbola, well, remember with the ellipse, we had two fixed points, the foci, and the sum of the distances was fixed to form an ellipse. Well, here it's the difference of the distances that form a hyperbola. Okay, so just like with the ellipse, our focus, we're going to let C represent the distance from the vertex to the focus, and the A to the vertices are where our hyperbola intersects the major axis, which this time is called the transverse axis. All right, so we're going to look at the standard form for the equation of the hyperbola. So now notice this looks a lot like the equation for the ellipse. The difference was it was a plus sign when it's an ellipse. A hyperbola has a minus sign. Now, with the ellipse, it was whichever number was bigger made the axis we go along. Here for hyperbolas, we don't care which number is bigger. Don't pay attention to that at all. It's which variable is positive. When the x is positive, we're opening horizontally like that. And when the y is positive, we're opening vertically like that. See, the y is positive here. Now, the other thing is the asymptotes are the lines that the hyperbola approaches as it moves out towards infinity. Whether I'm opening horizontally or vertically doesn't matter. It's the slope of the asymptote will always be the square root of what's under the y divided by the square root of what's under the x. And the c will always be whatever the positive one is squared plus the other one squared. And since it's a plus, the order doesn't matter, so I don't really need to pay attention to the order to figure out the c. Okay, so let's look at some examples. I want to sketch the asymptotes and graph the hyperbola that's here. Now, notice this is x squared and y squared in the top. So my center is at 0, 0. So the x is positive. I'm opening left and right. So I'm going to go up 5 units, the square root of 25. 5 units to the left and 5 units to the right to plot my vertex. I'm also going to figure out the slope of the asymptotes by doing the square root of what's here, always what's under the y divided by what's under the x. So square root of 7, square root of 49 is 7, over square root of 25 is 5. So 7/5 is my slope for the asymptotes. So we have two asymptotes, y equals plus 7/5 x and y equals minus 7/5 x. Then from the center, 0, 0, I move out 5 units to the left plot of vertex, 5 units to the right plot of vertex. Now, the easy way to get the asymptote is from that 5, go up 7 and down 7. And from this 5, go up 7 and down 7. That forms a box, and then your asymptotes go through the corners of the box. Then just draw the hyperbola through this point, coming close to those asymptotes. Through this point, coming close to those asymptotes. Now, to get the focus, remember, I'm taking what's here, 49, plus what's here, 25, and then square rooting it. Moving that far away from the center in both directions, that gives me negative square root of 74 and positive square root of 74. To graph it on my calculator, I again first have to solve for y. So when I solve for y, I end up with two equations, the positive and the negative of this square root function. The positive is the upper half in black, and the negative is the lower half. All right, now I want to graph this one. All right, first thing that we need to do is make sure we get a 1 where the 9 is. So I got to divide everything through by 9 first to get my 1 there. So we get 25y squared over 9 and 4x squared over 9. But I need the coefficient of the x squared and the y squared to be a 1, so I'm going to divide this 25 to the bottom and the 4 to the bottom. So it'll look like well, I think I'm going to be able to advance the slide. Try that. All right, so once we get that divided down into the bottom like so, My A is the square root of this guy, so 3/5, and the B is the square root of this guy, the 3/2. Doesn't matter. The y is positive, so I'm opening up and down. So opening up and down, I'm going from the center, which is at the 0, 0. We know that we're moving up to 3/2, or 3/5, sorry. Yeah, 3/5. And down 3/5. And then the square root of the other one was 3/2. So from this point, I move over 3/2, plot my point. From this point over 3/2, plot my point. This way 3/2, this way 3/2, draw my box, draw the asymptotes through them, draw the hyperbola through these points, straddling the asymptotes. Now, the other thing that we need is the foci. So to get that, we're going to go back to what we had, which was 4/25, and, oh, no, it wasn't 4/25. How do I undo that? Here's how I undo that. Sorry, we're right here. This is by 9, this is by 9, this is by 9. So this should have been 9/25 plus 9/4. All right, so if I add those together, I get 36 plus 225. 36 plus 225 over 4 times 25, which is 100. So 36 and 225 is 261. So the square root of 261 over 100. I need to plug that into my calculator to see about what that is, but that's going to be a little bit more than the square root of 2.5. So it's going to be just barely over 1. So somewhere in here and somewhere in here for the foci. Okay, up and down from the center. All right, now if I shift off the center of 0, 0 to hk, do just like before, x minus h and y minus k. Notice again, everything else stays the same, but now the distance that we're moving is away from whatever that hk value is, not from 0, 0. So I want to graph this guy. So my center is at -2, -3. So -2, -3, I'm opening up and down since the y is positive. So from -3, -2, I'm going to be moving up the y by 3 and over on the x by 2. So -3, -2, go up by 3 and it takes me to 1, down by 3 it takes me to -5, and then over by 2 on the x. So we're going to go over 2 and plot the point here for our box. Over 2, plot the point here for our box. Over 2, plot the point here for our box. Over 2, plot the point here for our box. Then draw the asymptotes through them, draw our graph. All right, now, the equations of the asymptotes, we're doing y, if you remember our point slope form, y minus y1 equals the slope times x minus x1, point slope form of a line. So the y1 is we're passing through that vertex. So we're going to go y minus 2 equals that slope, which is the ratio of what's under the square root of what's under the y divided by the square root of what's under the b. So plus or minus 3/2. X minus the x coordinate here is a 2. Oh, that's is a 3. And that should be a plus. So it's y plus 2 equals plus or minus 3/2 x plus 3. Go ahead and work that out, and that gives you two equations. Do one with the positive slope and the other with the negative slope. That form the asymptotes. Lastly is the value of the c. So we had a 9 and a 4, so 9 plus 4 is 13, so it's square root of 13. So square root of 13 is in between 3 and 4, because it's in between 9 and 16. So I'm going to go up a little bit more than 3 this way from the vertex and down a little more than 3 this way from the vertex. And that's where the foci would be. Now let's write the equation of a hyperbola having a center at 1, 2. Okay, so 1, 2, there's my center. Focus at 6, 2. So 1, 2, 3, 4, 5, 6. There's my focus. And a vertex at 4, 2. 1, 2, 3, 4. Well, if that's a vertex, that's a focus. I open around the focus. I got to be going that way. So the x has got to be the one that's positive. We're opening left and right. So I know that x is positive, the y is negative, and since the center's at 1, 2, I know it's x minus 1 squared and y minus 2 squared. And it's got to be equal to 1. Now we just need to figure out what the a and the b are. Well, notice that the distance from the center to the vertex, center to the vertex, is 3 units. So this is a 3. That's my a value. So this has got to be 3 squared here. Now, notice also that the distance from the center to the focus, is 5 units. 6 minus 1. So 9 plus b squared has got to be equal to 25. Let's do the math on that. We're going to see that the b has to be 16. B squared has to be 16. So x minus 1 squared over 9 minus y minus 2 squared over 16 equals 1. That's the equation of our hyperbola.